Okay, here we go, guys. It is the sample assessment paper. Here I'm attacking today. S1 IAL sample assessment paper. Here we go. And we're going to rock and roll this and whop it through really quickly because it's taken me ages to do these videos. So, first question, here we go. Number one. And so let's go with our highlighter. Let's see what they're giving us here. So Gary's compared the local attendance X at home matches. So attendance is X. Right, X equals the attendance. Let's highlight that. And the total number of goals scored. Number of goals is Y. And here we go, during a season for each of the 12 football teams. So that's my N equals 12. And then they've given us this S of XX, S of YY, S of XY. Cool. So they've almost given us the answers. This is going to be a nice easy one. So let me write this down. X equals attendance, Y equals goals, and N equals 12. Brilliant. Right, let's have a look at the question. So project moment correlation. So we know we're going to go straight to our formula tables as soon as we see all these S of X's and all that stuff. Go straight to our formula tables where we've got correlation and regression. Okay, because that's what we're going to need to use. I need to get some new formula tables because these are now like falling apart. Project moment correlation coefficient, here we go, project moment correlation coefficient, same one, and here's our formula. So I'm going to write that formula down. So for part A, and the formula is R equals S of XY divided by the root of S of XX times S of YY. Cool. Let's go for it. God, this is so easy. Let's have 2 marks. Yeah, okay. S of XY, have they? Yeah, they've given that to us here. So that's cool. This equals 8825 divided by square root S of XX. That's up here as well. Can't get much easier than this, can you? Good grief. 2 marks. 1022 500 multiplied by S of Y. Yeah, they've given that to us as well. 130.9. Oh, thank you. Here we go. I've had to go with my girlie's pink calculator because my one's now run out of battery. I don't know how. Right, so 8825 divided by square root. I'm going to whop this in brackets, so I don't know if that's going to work though. 1022 500 times 130.9 equals, oh yeah, 0.7628. 0.7628. Now there's a bit of controversy with this in the paper and their rounding, so I'm going to make that 0.76. Yeah, that's my answer to question 1. So, very nice, 2 marks, thank you. Yeah, we are up and running. And now part B. It's got to get harder, surely. Interpret the value of the correlation coefficient. Okay, so we've just worked out the correlation coefficient. We know that because we've got the same words here. Yeah, we've just worked it out. And what is that? That's correlation. So it's telling us the relationship between these two things. Is there a relationship between attendance of football matches and the number of goals? Okay, so we'll look. This is close to 1. So we've got a line that's going like this, and it's the values are quite close to 1. 1 would be perfect, and this is just slightly more spread out. So basically what we're saying is our X value is attendance and our Y value is goals. So basically we're saying the more people that attend a football match, the more goals there will be. This is the home goals, don't forget. So basically we're saying the more people that attend a home game the more goals. Oh, that'd be more exciting then. So a reason to get all your mates to go onto the football match is that there's a chance that there might be more goals scored. Wow, that'd be really cool, because honestly they do need to do something to liven them up a bit. Right, and then for part C, alright, hang on, I need to read all this. Helen's given the same data to analyse. In view of the large numbers involved, she decided to divide the attendance figures by 100, and then she calculated product moment correlation between x divided by 100. So this is coding that she's used, and y. Okay, and so then what will have happened to this correlation? Well, actually nothing would have happened at all. It would remain exactly the same. Okay, all she's done is she's made the numbers smaller, that's all. The actual data smaller, but the variation, or sorry, the correlation coefficient isn't going to change at all. So there's no change, and it would still be 0.76. Perfect. 4 marks for that question. It's not many marks, is it? But that only took me 6 minutes with all my waffling. Oh my word, how many sheets of paper? Okay, so now question 2. Question 2. It's a nice probability question, and they've given us a nice tree, so that's good. Okay, let's have a little look. So an experiment consists of selecting a ball from a bag and spinning a coin. Alright, so it's two events happening here. So we're going to have a ball and a coin. And the bag has got 5 red and 7 blue. Balls, red and blue. Do you know what? I'm going to write down the probability of the reds and blues to start off with, of the balls. So it's 5 out of 12 and 7 out of 12. That's easy peasy. And you never know, I might even get a mark for that. A ball is selected at random, its colour is noted, and then it's returned to the bag. So my outcome is going to remain at 12 all the time. When a red ball is selected, a biased coin with a probability of 2/3 of landing, so it's biased because we'd expect it to be a half, and it's got a probability of 2/3 of landing on a head. So let's keep going along here. So red, and then they throw a coin and it's got 2/3 probability of a head, so it's just going to be 1/3 there. Okay, that's just for the red. Right, now when the blue ball is when the blue ball is thrown, it's going to be a fair coin. So a fair coin is going to be like outcomes of a half, probability of a half. So when it's blue, it's a half here. That's a bit naughty, but I like that. Naughty but nice. Okay, complete the tree diagram. We've already completed the tree diagram and the associated probabilities. Right, well, we've already done all of that. Do you know what? I might actually fill out the end bit here. So we've got the probability of a red and a head is 5 over 12 times 2/3, and that gives me 10 over 36. And here we've got a red and a tail. That's going to give me 5/12 times 1 over 3 equals 5 over 36. And here we've got a blue and a head, and that's 7 over 12. I'm doing this because usually they're going to ask you about this diagram. They're not just going to ask you to fill one out and then just leave it. So it's 1 over 2 and then have nothing to do with it in the question. Right, so, and then finally, blue and a tail is 7 over 12 times a half again. That's another 7 over 24. Now another reason why I like to do that is because now I can check that everything's right by just adding this column up, making sure it comes to 1. I've got a very bad habit of always writing in these columns here, but you've got to remember in the exam you must not write in this column here at all. So that's that plus 5 over 36 plus 7 over 24 plus another 7 over 24. I should have been thinking ahead there. Right, so, and yeah, it comes to 1. Thank you very much. Okay, so I know that's all right. There's my nice, easy 2 marks. So let's have a look at what they're going to do with this now. Shivani selects a ball and spins the appropriate coin. So find the probability that she gets a head. Alright, so the probability she gets a head is this one here and this one here. We've done all the work, so this is nice and easy. So we've got probability of a head to start with was 10 over 36. And then we're going to have a head the second time, which was 7 over 24. And that equals 10 over 36 plus 7 over 24, 41 over 72. Okay. And now for the next part of the question. Given, oh no, it's one of those given questions. So now I'm going to have to put underneath here the probability of what they're going to say. Given that Tom selected a ball at random and obtained a head when he spun the coin, find the probability that he selected a red ball. Oh, I'm going to have to think about this. So this is the probability that he's red given that he had a head. Alright, okay. So we want the probability that he has red given that he had a head. Right, well, we've already just worked out here the probability that she got a head. We've just done that. So we know the bottom fraction is this. So we're going to whop that on the bottom. Thank you very much. Okay, now the top bit, red, so the top bit, this converts to probability of red, is red intersecting with a head, okay? And red intersection head, red head, was where we worked it out up here, is 10 over 36, all right? So that's the fraction that's going to go on the top, 10 over 36. Can I explain that any clearer? We're given a head, so on the top we do red intersection head, well, red and a head. Don't forget, intersection means and, that means and. So probability of a red and a head was 10 over 36. Right, okay, I think that's quite clear. Right, so let's work that out. 10 over 36 divided by 41 over 72. 20 over 41. That's the probability there. That's another 3 marks. There's a lot of marks here for quite straightforward questions. Let's have a look at the last one. Shivani and Tom repeat the experiment, so they each have a go at doing it. It's just basically doing the experiment twice. They just confused us with the names. So it means that we're doing the experiment twice. So find the probability that the colour of the ball that Shivani selects is the same as the colour of the ball that Tom selects. Well, that's really, so we're not worried about the heads. We're just looking at them selecting 2 reds. So we're either going to go red, red, or they could both have a blue ball. Well, probability of red and then red is going to be, the first person gets a red is 5 over 12. And they said at the beginning the balls are put back in the bag. So it's just going to be that squared. Where I have the word or, I always add. And then blue, blue is 7 over 12, and that's squared as well. Alright, so let's have a look at that. Because we're squaring it because we're saying the probability of the first person getting a blue times the probability of the second person getting a blue. Alright, so that's 5 over 12 squared plus, what was it, 7 over 12, 7 over 12 squared, and that's 37 over 72. 37 over 72. Now that was 10 marks. It wasn't really hard. If you just go through it step by step, it wasn't hard. Right, let's go on to question 3. Here we go. Okay, question 3. We're looking at a nice probability distribution table. That's cool. Right, good. Okay, so the discrete random variable x has got this probability distribution. So x is -1, all these numbers. The probability of x is this. And a is constant. So we've got an a here and an a here. We know the probability of any event happening always needs to, all of these different things need to add up to 1 always. So what we're saying here is that 1/5 plus a plus 1/10 plus a plus 1/5 has got to equal 1. Okay, so let's now simplify that. So we've got 1/5, add 1/5, that's 2/5, add a 10th, which actually is another 2/5. So that's 4/5 plus 2 lots of a equals 1. So if I take this away now, I've got 2 lots of a equals 1/5. So therefore a has got to equal 1/10. Yeah? Yeah. Okay, now do you know what? I'm going to now move this table down to the bottom because they're going to ask me, look, you can see they're asking me expected values of x and the variation and that sort of stuff. I need to have some extra things on the bottom of my table. So I'm going to put x equals, I've got -1, 0, 1, 2, 3, and let's make that a bit longer. Probability of x being x is 1/5. Very untidy. A is 1/10. We just calculate that. 1 is 1/10. 2, that's 1/10 as well. Everything's pretty much 1/10. And 3 is 1/5. Okay. Right, so 2. I'm just checking the addition again because I think I've made a mistake here somewhere. Okay, so a is 1. Hang on a sec. Okay, so I thought that was all a bit crazily stupid, which it is. So teach me to hurry things. I made a mistake here. Let me mark it in red. Oh, orange even. Look, big mistake. Dart. So 1/5 is not the same as 2/5, is it? I needed to change this to tenths. So that's 2/10. 2/10 there. Oh, dearie me. Get rid of that. That stays as 1/10. So basically that all adds up to 5/10. Oh, that's stupid. So that 5/10 is a half. So let me change this over here. I think my orange pen is not working very well. So this was a half. 1 take away a half is a half. And now I need to divide by 2. That gives me a final answer of 1/4. So I'm going to rewrite this down here because it's poor what I've done. Very poor. So -1 is 1/5. A is 1/4. Number 1 is 1/10. 2 is 1/4. And 3 is 1/5. All right, and we know that's going to add up to, 1. Oh, and it's symmetrical as well. That's nice. So we've done A, so now on to B. Write down the expected value of x. Well, actually, because it's symmetrical, I know it's going to be 1, but we'll work it out anyway. So we've got the expected value of x here. So we've got -1 times 1/5 is -1/5. 0 times 1/4, 1 times 1/10 is 1/10. 2 lots of 1/4 is 2/4, and 3 lots of 1/5 is 3/5. Okay, now if I add all of these up, it should come to 1 unless I'm making another stupid mistake. So -1/5 plus 1/5 plus 1 over 10 plus 2 over 4 plus 3 over 5 is 1. So there we go, that's 1. Don't forget you will need to show you working out. So, whoa, oh no, that's 1 mark here, that's easy. C, right, variance of x. Okay, so this is where I need to work out expected value of x squared minus expected value of x squared. So here we go. We just found out that's 1. Right, so now I need to have another one here. E of x squared. So we've got minus 1 squared times this. Minus 1 squared is 1. 1 times that is going to give me a minus 1 over 5 again. Okay, that's another 0. 1 squared times 1 over 10. So there should be a plus there because it's this row here that I'm looking at. Bit tired. I had a hot chocolate half an hour ago. I should have made it a coffee. Right, so 1 squared, that's 1 times that is 1 over 10. 2 squared is 4. 4 times this is 4 over 4, which is 1. And then 3 squared, 9 times 1/5, that's 9 over 5. Let's add that row up. 1 over 5 plus 1 over 10 plus 1 plus 9 over 5 equals 3 and 1/10, 3.1, 3 and 1/10, which I'm actually going to call 3.1. Okay, so here we go. So this is 3.1. Take away this, which is 1 squared, gives me 2.1. Okay. Oh, now we've got to do, that was C. Right, D. Here we go, D. So they're saying that there's a random variable called y, and it is found by doing 6, take away 2 lots of x, and find the variation of y. Okay, right, so the variation, so we can ignore the 6 because that's just going to make it a higher number. It's not going to make any difference to the variance. But this we need to square. If I write this down, so we've got minus 2 squared times the variance of x. So that's going to be 4, and the variance of x was 2.1. So that gives me an answer of 8.4. Okay. And then E, calculate the probability that x is greater than or equal to y. Okay, let's have a look then. So let's plug in some values. I've got x could equal minus 1, could equal 0, 1, 2, and 3. This is what x could equal. Right, when x is equal to minus 1, I've got 6 minus, sorry, is x bigger than or equal to 6 minus 2x, which is what y is, okay? So here x minus 1, is that bigger than or equal to 6 minus 2 times that, which is going to be a plus 2? Minus 1 is bigger than 8? No, impossible, right. When it's 0, is it greater than or equal to 6 minus 2 times 0? Which would be 0. So is it? No, it's not. 6. Right, so when it's 1, is it greater than or equal to 6 take away 2 times 1, 2 times 1 is 2, 6 take away 2 is 4, is 1 bigger? No, it's not, so it can't be that either. This is all seeming a bit of a waste of time. Is 2 bigger than or equal to 6 take away 2 times 2? 6 take away 4, yes, that's equal, so it could be 2. And is 3 greater than or equal to 6 minus 2 times 3? Well, that would be 6, so that would be 0. So yes, it could be that either. So we know then the only possibilities for this to work are for the values of 2 and 3 are the only values it works. So now we need to find out the probability. Oops, sorry about that. So we need to know the probability when x equals 2. So what is that? When x equals 2, the probability was 1/4 from our table here. And so we've got an or, which is, or it could be 3, or the probability that x is 3, and that is from here 1/5. So basically we've got 1/4 plus, because we have the or here, 1/5, and that equals 9/20. That's the answer to that question. All right, and that's the final 3 marks. Okay. For my guys that are taking the paper this year, that's 2020, we've said whenever we hit the coding, we're not going to do it. That would be 5 marks that we wouldn't do, but it's up to you if you can follow it and you think you can remember. Right, let's have a bit more energy getting into this now. Oh, a Venn diagram. Yay! So another probability question. Here we go. I'm trying to squeeze it all in. The Venn diagram in figure 1 shows a number of students in the class who read any of 3 popular magazines, A, B, and C. Quick look. So basically it means that nobody reads A and C. But lots of people read it. You know, if you read B, no, not all of them, but you can read A or B. A lot of them are. Okay. So, how many people are in this all together? 5, 10, 20. So there are 30 people. Yeah, just stop and have a little look. There are 30 people altogether in the survey. 10 people don't read any magazines whatsoever. Okay. So now let's have a look at the question. So part A. Show the probability that the student reads more than one magazine is 1/6. So if they read more than one magazine, they're going to be here. It's going to be these people here because they read A and B, and it's going to be these people here. They read B and C. So that's actually quite easy, isn't it? Because that's 5 people altogether. And how many people are there in the survey? There's 30. So if I simplify that, it makes 1 out of 6. So I've done that. That's 2 marks. That's insane. Right. Find the probability a student reads A or B or both. So that's all of A and all of B. So that's 4 plus 2 plus 5 plus 3. So that's 14 out of 30. 7 out of 15. I'm struggling to see that this could possibly be the question because it all just seems so very, very easy. I don't understand. Anyway, these are really simple questions. Right, so part C. Write down the probability that a student reads both A and C. So that they read A and they read C. Well, it's impossible. They can't. So that's impossible. Possible. So it's a 0 probability. Right. It just seems such an easy question. Right. Here we go. Given that a student reads at least one of the magazines, so we know our probability is going to have at the bottom that they read one of the magazines. Well, what's the probability that they read at least one of them? It's 20 out of 30. 20 out of 30 people in the survey read at least one of the magazines. Okay. Find the probability that the student reads C. So here we go. We're going to go probability that they read C. Do you know what? We don't even really need to do this. Look, find the probability the student reads C. So the probability that they read a magazine, well, that's out of 20, isn't it? And the probability that they read C is just here. So it's 9 out of 20. That's just, again, just using the Venn diagram. And then finally, so determine whether or not reading B and reading C are statistically independent. Right, well, for them to be independent, we know that we've got to use these rules. Probability of A times the probability of B is the same as the probability of A times B. All right, this is the rule we need to use to prove independence, and we need to go into the exam knowing it. Okay, so actually we're doing B and C. So what is the probability of B is, so the probability of B equals 10 out of 30. I'm going to write that as 1 over 3, it's so much simpler. And the probability of C is, there are 9 out of 30 people, which can cancel down to be 3 out of 10. Right, probability of B is 1 over 3 times the probability of C, which is 3 over 10, is going to be 3 out of 30, which is same as 110. Now, is that the same as, well, actually, we can see from our diagram, we don't even need to do anything else. The amount that's in the middle of them here, up here, is 3 out of, altogether there's 10, 16, hang on. Yes, so it's 3 out of 30, and that's the same as 1 over 10. So yes, they, oh, sorry, you can't see what I'm writing. Yes, they are statistically, oh, that's a word, long word, independent. There you go. 2 for 5, 10 marks. That's nuts. Right, okay, next one. Question 5, here we go. Question 5. So here we are. A teacher selects a random sample of 56 students to the nearest hour and records to the nearest hour the time spent on watching telly. Sorry, I'm just looking at the table because hours, we've got continuous data here and there's no mid parts here. So I'm going to just pop those down to start off with. So here we go. 10.5, 20.5, 25.5, 30.5, 40.5. Okay, so I'm going to do that before I even start because usually they're going to use that to trip you up somewhere. Very naughty. Right, so 6 people watch between 1 and 10 hours or 1 and 10.5 hours. And they've worked out the midpoint for us. I'm going to have to put 0.5 there then. I'm going to have to put 59.5 here. So they've worked out the midpoints, they've added the 2, divided by 2. Right, but they haven't done all of them, so it looks like we've got quite an easy question coming up now. So for 2 marks, find the midpoints of 21 to 25 and 31 to 40. Okay, easy, easy. So we're going to add these, divide by 2, that gives me a 23 here. Add those 2, divide by 2 is going to give me 35.5. Okay. 2 marks, yes. Right, okay, now they're going to ask us a histogram question. Right. So we're going to have to do a drawing. I'm just seeing if I've got enough room to get the table in and the drawing. Right, let's do our best. So histogram was drawn to represent this data, and the 11 to 20 group, this one here, was used. Okay, so let's draw this. So here's our table B, our histogram. So 26 to 11 to 20, so that's 10.5 to 20.5. Okay, and the frequency inside here is going to be 15. All right. Okay. Now let's see what else they're telling us. Right, so this is my real one. I'm going to have to do another drawing here, which is going to be the one that they've used. So the one that they've used is, they've said they've got a bar width of 4. Okay. They've got a bar width of 4, and the one in our drawing is 10. So let's think, 10 times what made 4? So that's 10 divided by, well, 10 divided by 4 is 2.5. So 10 divided by 2.5. So when I'm going this way, I'm going to have to divide by 2.5 to find the width. Okay. And when they did theirs, histogram width and a height of 6. So on their one, they've got a height of 6, which gave me an area of 24. Alright, so now let's compare the areas. To go from my area to their area, it's going to get bigger. I've got to multiply it. So to multiply it by what? Well, 24 divided by 15 is 24 divided by 15 is 1.6. So if I times it by 1.6, then that's going to give us my area. Okay, now let's have a look at what they're asking us to do. I thought I saw a purple pen. Yeah, I've got a purple pen. Yeah. So now they want us to do one for the 26 to 30 group. Well, the 26 to 30 groups, that's going to be 25.5 to 30.5. So my width here is 5. What did I say I have to do with the width? I need to divide it by 2.5. So 5 divided by 2.5, very conveniently, is 2. Okay, so the width on my new drawing is going to be 2. Let me do that here. It's going to be 2 on my scaled drawing. Okay, let's have a little look at the area next. I think it tells us. Alright, okay. So for my 26 to 30 group, my frequency, my area is 13. So I'm going to put in here 13. We want it to be 13. Okay. So on the drawing that I'm going to, on my new, this is my new drawing. My new drawing. Okay. And I said the area, if we go over here, the area, my area's got to be times by 1.6. So in my one that they've given us the details for, we need an area of 13. So on this one, I'm going to times it by 1.6. 13 times 1.6 is 20.8. So I want my area here to be 20 point, can you see that? Yes, you can. 20.8. Okay, so my area is 20.8, the width is 2, and the area is this times this. What times 2 makes this? So I'm just going to have to halve this. So my height is going to be 10.8. Alright? So that's the easiest way I can think of doing the calculations with histograms. So hopefully you followed all that. So there we go. If not, you can just replay it. The joy of YouTube. Right, okay, so that's B, that's 3 marks. So C, which is now 5 marks, I would expect to take me a little while. So C, estimate the mean and the standard deviation of the time spent. Okay, so the mean is, let me write down the mean. We know it is going to be each of these multiplied. So midpoint 5.5 times the frequency plus next group 15.5 times the frequency plus 23 times 11, etc. Boom, 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 all the way to the end, and that comes out as one I've worked out earlier. I think, yeah, 1316.5 divided by the number of people, so that's that, and that comes out at 23.51. 23.51, does that look like a decent average? The number of hours students been watching the television. 23, yeah, that's about here, so we're going to go with that. Sorry, it's about here, so we're happy. That looks like it's a decent average. Right, that's the mean, and now we need to do the standard deviation. So don't forget, standard deviation is the square root of the variance, and then we work that out by, here we go, square root of expected f of x squared divided by the sum of f, take away the mean squared, so that's 23.51 squared. Okay. Have they done any oh, they haven't done any calculations for us. That's really mean. So here, don't forget we need to do, it's 5.5 squared times this, 50, and that times that, this squared times that, this squared times that, this squared times that, and this squared times that. Alright, so I'm just going to write down a little bit of all of that. So it's 5.5 squared times 6 plus 15.5 squared times 15, etc. Going on and on and on. And that came out at 37378.25 divided by 56 equaled 667.47 approximately, and then we've got to square root that, don't forget. So the square root of 667.47 equals 10.71. There we go, 10.71, and that was the standard deviation. Let me underline these because everything's getting a bit messy now. That's the standard deviation, that's the mean. Okay, and that was 5 marks. And I'm going to have to go onto a scrap piece of paper because I've run out of room here. So let me just grab a piece of paper. Here we go. So it says question 7 at the top, but it isn't. It's question 5. And let's have a look at the question. So that was C. D. Use linear interpolation. Right. I'll put this paper here as well. To find the median. Okay, right. So as soon as I use those words, linear interpolation, we use this. And we go back up to here. And the median is the middle value. There were 56 people. So we know that 56 divided by 2, 25, 28th value. Okay, 28th. So if we add these up, 6 add 15, 21, so it's going to be in this group here. Alright, so the median is going to be in this group. So this is the one that we need for our table. Right, the lower value is 20.5, the upper value is 25.5, and it starts at 21, the 21st value is here, and it goes up to 32. The 32nd is there, and we want the 28th, which is going to be round about here somewhere. Okay, so we know we're going to start in this group at 20.5 plus, this is got a width of 7 out of 11 times, and the whole of this width is 5, so that's going to equal I've gone a bit slow now. I know I've got a cold cup of tea here somewhere. 20.5 plus bracket 7 over 11 times 5 bracket equals 23.68, and then 1/8 recurring. 23.681. These are recurring. Right, okay. That's approximately 23.7. That's the median. Okay, 2 marks. Yes. So, on to the last part now. E. Let's read the question. Teacher estimated the lower quartile and the upper quartile to be these. And now we're going to have to state, given a reason, the skewness. So let me write it down. Q1 is 15.8. Q2, we've just worked out, is the median is 23.7. And Q3 is 29.3. Okay, now to work out the skewness, we've just got to work out the difference between these. So here we go. Q2 minus Q1 is 7.9, and Q3 minus Q2 is 5.62. So this is definitely bigger than this. Okay, so let me just sketch that. So I've got here, if I imagine my box. So this bit over here, I've got Q2 over here because this is 7.9 and that's 5.62. So if I had to draw how this looked, it would be going like this. Yeah, because this gap here is, so this is, because it's going this way, that is negative, it's pointing to in the negative direction. So we'd say it's a negative skew because Q2 minus Q1 is bigger than Q3 minus Q2. And don't forget to write all this, yeah, because it's like 2 marks and you don't want to miss any marks. And that's the end of question 5, I think. 5, 10, 14 marks. Quite a nice little question, 14 marks. And strolling on, hopefully we're nearly there now. Number 6. Are there any 6 questions? Oh no, there's a 7 as well. Right, I'm going to pause this while I have my cup of tea. Okay, I am refreshed and revived. So now I'm ready to hit question 6, which, whoa, is a great big long whole page worth. Let me get a piece of paper ready to write the answers on. Okay, travel agent, so flights to different destinations, and the distance D is in 100 kilometers. Let me write that here. Distance, and that's in measurements of 100k, and F stands for the fare, so that's how much they cost in pounds. All right, and there are only 6 destinations. N equals 6. Not a very big survey, was it? So just to go to this one, they travelled 220 kilometres and they paid 18 quid. Okay, and they've done some nice calculations here for us. That's cool. That's very nice. And so here we go. To start off with, using the axis below, complete the scatter graph. Well, that's easy. So that's 2 marks. try and do this quickly. 2.2, distance 2.2, 18 quid. Don't forget to always check the axes. 2.2, 18, there. 4 and 20, 6 and 25, 2.5 and 23, 8 and 32, and 5 and 28. There we go. So they look to me that they're kind of going like that. There's a positive correlation there, yeah? Okay, so that's 2 marks. Right, so explain why a linear regression model may be appropriate to describe the relationship between F and D. And so we're going to put here because the points are close to a line. That's pretty much it, and you could draw the line there if you want to, just roughly. Right, okay, so that's that. 1 mark. Right, here's a nice meaty one because now we're moving on to 4 marks. So calculate S of DD and S of FD. Right, so tables, here we go. S of DD to start off with, and we're back to this table again, which we've already used once in this exam, haven't we? Now we're going to use it again, together with a sheet of paper. So here we go. So S of XX is, use this, sum of x squared minus the sum of x squared divided by n. Right, let's get going with that. Have they worked all of that out for us? Oh no, they haven't. Yes, they have. Have they? No, they've done some. So they've done the S of, this is the S of DD, yeah. They've done the sum of D squared, so that's nice. That's 152.09 minus, and we're looking at D, so basically we're just going to do all of that. Here we go. Okay, so we add up all of D. D added up is 27.7. 27.7 squared divided by 6 equals 24.21. Okay, and that's that one. Let's highlight it. And also S of FD. S of FD equals, right, so from your formula tables again, here we go, it's this one here. Okay, so it's the sum of FD, take away sum of F times the sum of D divided by N, and I think they've given us the sum of FD, yeah they have. So that's 723.1, take away sum of F times the sum of D. Well, we already know the sum of D is 27.7, 27.7 times the sum of F. So if I add all of these up, they come out at, I'm trying to save a bit of time here because I think 14 point, no, not 14.6. Let's see what they come out at. Plus 20 plus 25 plus 23 plus 32 plus 28. 146. 146 divided by 6, and that equals 49.07. Right. Okay, so that was 4 marks. Right, so for D, that was C, D, calculate the equation of a regression line of f on D, given your answer in the form f equals a plus bd. F equals a plus bd. Okay, regression lines. So we know we've got a formula on our formula sheets for regression lines. So here we go. Y equals a plus bx, which is pretty much how they want it. Where a equals this, and we need to work out b first. So b is the s of xy divided by the s of xx, which we've just worked out. So that's rather convenient. So let me write that down. B equals the s of xy divided by the s of xx. So from what we've just written down here, s of xy, so that's that 49.07 divided by 24.21, and that equals 2.026. Although it's going to be going on a bit. So that's my B. And now let's find A. A equals, back to our tables, A equals y bar take away bx bar. Y bar take away bx bar. So let's find out y bar. The average of y is sum of all of y, which we've added up as 146 divided by 6. So 146 divided by 6 is 146 divided by 6 is 24.3 recurring. And x bar is 27.7 divided by 6, which is 0.7 divided by 6. 4.616 recurring. 4.616 recurring. Okay. So therefore, my A equals y bar, which is 24.3 recurring, minus 2.026, which is B, times 4.616 recurring. So my A equals 24.3 minus 2.026 times 4.61 equals 14.95. Okay, so that's 14.946. So I'm going to say roughly 14.9. Yeah, I think I'll round it to that. Okay, so that is my A. So I'm going to go for F equals 14.9 plus 2.03 D. Okay, because it's A plus B times D. Alright, that is my equation for my line of regression. Excuse. How many marks was that? That was 4 marks again. Okay, that's good. So it wasn't a waste of time. Right, E. Give an interpretation of the value of B. Well, B was this bit here, wasn't it? This is B. So what are we saying? We're saying that every time we go, our distance increases by 1, our fare increases by 2.03. But don't forget that our distance was in 100 kilometers. So for every 100 kilometers traveled, the fare increases by £2.03. Okay, that's E, 1 mark. Okay, F. Let me try and squeeze F on the same page. Okay, F. So Jane is planning a holiday and wishes to fly to a destination that is T kilometres away. Arrival travel agent charges 5p per km. Okay. So they just charge a flat rate. This rate that we're looking at here has got a starting rate of 14.9 and then adds on this for every 100 kilometres. So the other one, the other travel agent, charges 5p per kilometre per km, or if you like, that's £5 per 100. So there's going to be a time when it's cheaper to go with them than it is to go with them. And they're asking us to find out, when is the first travel agent, that's this one, when is this cheaper than that? So when is 14.9 plus 2.03D less than 5D? Okay. So let's have a look. Let's do this. 14.9 and let's take less than 2.97D. So now let's divide that. 14.9 divided by 2.97. 14.9 divided by 2.97 equals 5.02. 5.02 is less than D. So when my distance is less than 502 kilometers, it's cheaper for me to use the first company. All right, so when my distance is less than 502 kilometers, we should just go with the first company, because basically the other this one is more, obviously it's going to be more expensive. 5p per kilometre. It's going to, come out as being more expensive than this at a certain point. And the point we've worked out is at 502 kilometres, because this is charging almost double per kilometre travelled. Well, more than double per kilometre travelled. But on this one, we're starting off with a flat fee. So before we've even taken off, we've said, oh, it costs that amount without even taking off, on average. Okay, so that's answered that question. Right, we're ready to get to the last question of the paper. Okay, so let's look at this. Okay, it's a nice normal distribution question, so that's cool. And it's about distances travelled to work by the employees at a large company have got this normal distribution. Right, so A. Find the probability that a randomly selected employee has a journey to work of more than 20 kilometres. So we want the probability that this person travels more than 20. Okay, so let's draw our distribution here. Don't forget this bit here is Z, and this here is an average of 30. So our person with 20 is down here, and we want to know the probability that they are above that. So this is going to be a whopping big probability, okay, that they're more than that. Right, so now we've done our diagram, we just need to put in our information. So we've got here Z equals, so it's 20 take away 30 divided by 8. And that equals, that's minus 10 over 8, which is minus 1.25. Right, so let's go to our tables. Okay. And don't forget, that's our Z value, so we can't find a minus, we're going to have to find the figure over here, okay, for 1.25. Okay, so 1.25 is Z value, and that's got a probability of 0.8944. 0.8944. 0.8944 is the area under the curve at this point. Now, not forgetting that we actually wanted all of this, and this is symmetrical, yeah, so we've found at the moment everything from there up to there, which is basically the same as everything from here down to there, because it's all flipped over. So that is the answer to part A. 0.8944 is the answer. Okay, good. Let's move on to part B. Find the upper quartile Q3. So the upper quartile Q3 we know is 0.75. It's at 75%. So let's draw a curve. Here we go. That's 30. This is Z. And so now we want 0.75. And we're looking at the area. So it's bigger than half, obviously 50%. So we want it when all of this in the middle is 0.75. So we've now found, we know the area, we need to find the Z value. So we're going to go to our tables for 0.75. Just check to start off with that we haven't got it in our table at the back here. 0.75, no we haven't. 0.25, no it's not there. So here we go then. So we are looking at the probability columns, not the Z column. We want to find out what Z is. So 0.75 is here between these two values, and it lies closer to 0.67. So that's the value we're taking, 0.67. 0.67, alright, is our Z value. So now let's use our little Z equals, we don't know what this is, x minus 30 divided by 8. And we know we want that to equal 0.67. Okay, so this equals then, so we're going to do 0.67 times the 8 and add the 30 to find out what x is. So 0.67 times the 8, because the 8 comes up here, and then we're going to add the 30, and that gives me 35.36. 35.36. Does that look right? Well, it's bigger than 30. Yeah, I'm quite happy. So at least we've got it kind of the right way around. Alright, so that's good. So that's the answer to that one, 35.36. We're stalling through this question. C, write down the lower quartile. I don't know why they've asked us to do that when it's the same as the other one. But anyway, let's see. So part C, Q1. 30 here. This time Q1 is equal to 0.25. So here we go, there's our x, and we want this to be 0.25. Well, actually, it's going to be totally symmetrical to this, isn't it? Because if we look here, we've got 0.25 there. Yeah? And so flipping this over, we know this is minus 0.67 here. And we also know that whatever the distance is between here and here, it's going to be the same here. So if this was plus 5.36 to get to there, we know we just need to take it away. Probably shouldn't be using that colour. That was plus 5.36 to get there. So now we just need to go here, minus 5.36, and that will give me the x. So 30 minus 5.36 is 24.64. So x equals 24.64. All right, that's for Q1. That's for Q3. And we know Q2 is 30. Okay, that was part C. So now we're moving on to here. Okay, they're talking about outliers now. And this is why they've asked us to find Q3 and Q1, because that's what we've just found here. So we know that Q3 was 35.36 and Q1 was 24.64. Okay, so now we're just going to plug those into these values to find out what H and K are. So here we go. H is Q1, 24.64, minus 1.5 times the difference between Q3 and Q1, which is 10.72. That's 8.56. So H is 8.56 and K is Q3, 35.36 plus 1.5 times the difference between the two again, which was 10.72. 51.44. Okay, so finally, 3 marks. That's going to be a bit tricky. Find the probability of distance travelled to work by this employee who they've selected at random is one of the an outlier. So they've got to be below that or above that. So it's a probability that this person is either less than 8.56 or they could be greater than 51.44. Okay, so we're looking at them. Do I need to do a drawing? Yeah, I think I do. So let's do this. So let's do a drawing for this one. Here is 30. Here is 8.56. And we want them to be in this little bit here, so we need to find out what that area is there. And I already know that this is minus 0.67 from when I did this drawing here. Okay. Oops, no I don't. Sorry, I'm getting muddled up with that question going back there ages. Right, so here we go. Yeah, sorry, no, this is not 0.67, being really stupid. So here we go. Z equals 8.56 minus 30 divided by 8. That equals 8.56 minus 30 divided by 8 is minus 2.68. Minus 2.68. So this is minus 2.68. That's my Z value. Let's go to the tables. 2.68. 2.68. That's going to be closer to 2.7. That's 0. Sorry. Here on our tables, 0.9965. 0.9965. 0.9965. 9965. Right, so that's all the area going all the way up to here, and we just want this bit here, so we're going to take that away from 1. 1 minus 0.9965 is 0.0035. 0.0035. That's the area of this part here. Okay, now we know for the other one it's going to be the same because they're symmetrical, aren't they? Because well, we just took them away from each other and used the same distance and everything. So we want this area here as well, which is going to be the same. 0.0035 is going to be that area there too. And we want it, so it could be this or it can be that. So we're going to add them together because we've got that golden or. So we add them together. So 0.0035 plus 0.0035 gives us 0.007. Okay, that's the probability that they're going to be an outlier. That's the end of that paper. Do you know what? That's taken me 1 hour and 15 minutes. And I know that I've spent a lot of time talking through things, but it's only an hour and a half for your exam. So you have got to work really, really quick to get through it.